Alright, this is the last video for the test 2 review. We're going to go over pages 6 and pages 7. We have here, sorry that it's so blurry, we have 50y squared minus 98x squared. And because we have two terms and they're being squared, it's probably going to be the difference of the squares. The only reason it wouldn't be the difference of the squares is if both things weren't perfect factors. So, the very first thing we must do then is look for the greatest common factor. So between 50 and 98, the GCF is 2. So we have 25y squared minus 49x squared. And so since 25y squared and 49x squared are both perfect squares, we're going to factor that into their perfect squares. So it's a plus b times a minus b. Okay, where a is whatever you need to get whatever you need squared to get 25y squared. Sorry. So it would be 5y and 5y, because 5y times 5y is 25y squared. And for the second term, we get plus 7x minus 7x, because 7x times 7x is 49x squared. Don't forget the 2 that you factored out at the very beginning. Alright, this next problem, 20x squared plus 27xy plus 9y squared. Alright, so the very first thing we must do is check to see if there's a greatest common factor. Between 20x squared and 27xy and 9y squared, there is no greatest common factor. So then what we're going to want to do is take the 20 and multiply the 9. Sorry, we're not multiplying 9. We're going 9 times 20. So then we have this equation, x squared plus 27xy plus 180y squared. Then what we do is we factor this new trinomial. Whenever you have an x first and then a y at the end, they will factor where you have an x and a y. You just need to find whatever the constant is on y. Okay, so the y is kind of like a second thought to this problem. So we're looking for the two things that multiply to get to 180, same sign because it's a positive 180, and add to get to 27. Well, that there would be 15 and 12. And you are allowed a calculator, so you can keep dividing and guess and checking until you find the pieces. Alright, now we are not done with the factoring, because if you remember, we did here take that 20 and multiplied by 20, so we absolutely must go back and divide the 20 back out. We will reduce each of those constants. 15 divided by 20 reduces to 4. Let's see. 5 goes into both things. Sorry, so 3/4 y. And 20 or 12 over 20, they both have a common factor of 4. That reduces to 3/4. Alright, and then the last thing we do there is we're going to bring up any remaining denominators. Sorry, I made a mistake. It's not 3/4, it's 3/5. So we'll bring up any remaining denominators. So I have 4x plus 3y and 5x plus 3y. And you could FOIL this back through to make sure you multiplied it the right way. Alright, this next question, number 19b, says factor completely and state if the polynomial is prime. So the very first thing we must do, factor completely, is to look for the greatest common factor. So here we have a 6. We can factor a 6 out from both of these terms. Then we have the formula a cubed minus b cubed. So I have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So let's go ahead and follow that formula. We have our a is going to be what cubed gives us x cubed. So that would be x. And our b will be equal to 1. Do not worry about the negative sign on that. It's just a 1. So then we follow it into the formula. We end up with x minus 1 times a squared, so x squared, plus a times b, so x times 1, plus b squared, so 1 squared is 1. And then we are done with the factoring. If it were a plus, you would use the addition formula as opposed to the subtraction formula. Alright, the last one on this page is x squared plus 8x plus 16 minus 36y squared. So, make sure that alright, this next one has 4 terms, so we're going to factor by grouping again. This is a different type of factoring by grouping, and that is because if you take a look at the first 3 terms, they form a perfect square. So if we were to factor this into a perfect square, and we know it's a perfect square because the factors of 16 is 4 and 4, and that adds to 8. So that means we would have the factor x plus 4 squared. And we're going to subtract that, x plus 4 squared. So that becomes the perfect square trinomial. Then we have 36y squared. So this is now in the form a squared minus b squared, where our a is equal to x plus 4, and the b is going to be 6y. So what we have here then is the a squared minus b squared formula. We have x plus 4 plus 6y, x plus 4 minus 6y. Alright, just look to make sure you can't combine any like terms. In this case, it's completely finished, so this is our factored form. Alright, that is it for the first page. Let's go on to page 7. Alright, let's go problem 21b. And I'll tell you that the iPad does not take very good pictures, so sorry that this is so blurry. We have 6x cubed y minus 15x squared y plus 9xy. So think to yourself, what is the very first thing that you must do? And that is to factor out the greatest common factor. The GCF between 6, 15, and 9 would be 3. The greatest common factor between x cubed, x squared, and x to the first is x to the first. It's always the smallest power that you can of the multiples. So then we have y, y, and y. So y is the... Oh my goodness, I can't make that y look like a y. Okay, there we go. So 3xy. Then we can take out 3xy from each term. We are left with 2x squared and minus 5x And then here lastly 3, just 3. So we are going to factor 3xy times, we're going to factor out 3xy and we get the new trinomial of 2x squared minus 5x plus 3. Okay, so we need to take 3xy and we need to find the two factors that multiply to get the 2x squared minus 5x plus 3. So the very first thing we'll want to do is take that 2 and multiply the 3. We have x squared minus 5x plus 6. Well, that's a pretty simple factoring. Two things that are the same sign that multiply to get to 6 and add to get to negative 5 would be x minus 3 and x minus 2. So remember that though you did multiply that last term by 2, so we need to go and divide that last term by 2 at the end. We will reduce any fractions that can be reduced. So we have x minus 3 halves times x minus 1. And then anything that has not been able to be reduced in the denominator will come up on its x. So then our final answer here will be 3xy times, bring that 2 up, 2x minus 3 times x minus 1. And there we go. That is our final factored form of the polynomial. All right, let's take a look at the next problem on this page. We have to take this equation. It says solve the polynomial equation. Make sure that you're reading the problems, because if you see this, you may just think to factor and be done, but that is not what you're doing. You are solving the equation, which means that we must first factor the polynomial and then find the zeros. So first factor out a greatest common factor. We have 2 times x squared plus 6x minus 40 equals 0. Then we're going to factor the trinomial into x plus 10 and x minus 4. Remember, if it's a negative at the last term, you will have the opposite signs, and that means you will subtract the two factors to get what the middle term is. All right, now once we have our factored form, we're going to set each of the factors equal to 0. So, can 2 equal 0? The answer is no, so we don't need to worry about it. The next one, x plus 10. If we were to subtract the 10 over, we get x is equal to negative 10. And here we will add the 4 over. We get x equals positive 4. So x equals negative 10 and positive 4 are my two solutions. One thing you can do if you're not sure if you've done the problem right is you can plug the two solutions back into the original equation and see if you get the equation to equal 0 or not. That's called substituting. You're substituting the answers into the original equation. All right, let's go ahead and take a look at this next one. We've got x cubed plus 3x squared minus x minus 3. X cubed tells you that you must have 3 solutions. So what we're going to do is we want to factor this by grouping. So factor out an x squared, we have x plus 3. Factor out a negative 1 here, you get x plus 3. Then we're going to factor out the x plus 3. I'm not going to spend a lot of time talking about the factoring on this because We just spent a long time talking about factoring. So we have x plus 3. We can factor x squared minus 1 into x plus 1 times x minus 1. And we set each of the factors equal to 0. So when does x plus 3 equal 0? When does x plus 1 equal 0? And when does x minus 1 equal 0? Subtract the 3, we get x equals negative 3. Subtract the 1, we get x equals negative 1. Add the 1 over, we get x equals positive 1. And there we go. Those are our 3 solutions. And once again, you can plug those 3 solutions back into the original equation to see if you've gotten it right or not. All right, this last question here will be an example of like an extra credit type question. So we have 2x minus 3 all to the 4th minus 81. If you go and you set this equal, or use the a squared minus b squared, we would have here that our a would have to be 2x minus 3 to the 2nd power, and our b would be 9. So what you end up with is 2x minus 3 squared plus 9 and 2x minus 3 squared minus 9. Alright, so this right here is prime. We cannot factor that any further, but this one right here can be factored even further. So the first factor, 2x minus 3 squared plus 9, stays as is. But here, our a would be 2x minus 3, and our b would be 3. So we end up with 2x minus 3 plus 3, 2x minus 3 minus 3. And then kind of clean the problem up a little bit. If anything combines, do combine it. We've got 2x minus 3 plus 3 is 2x, and 2x minus 3 is minus 6. Okay, one thing that you can do here that won't be part of your problem, but you could factor a 2 out from this, but we're not going to worry about that. So in this case, we will have our final factored polynomial, sorry. And that is it for the test review. Remember that the test is from the 15th, which is today, through the 25th. Good luck.